of the David Winter's book, where you get a table and a figure. Very nicely, the anthropometric data is summarized in form of a figure and a table. Okay? Then you assume the musculoskeletal joints. So you need to locate and orient with reference to a local coordinate system and global coordinate system, right? And you need to know what are the constraints. Now, these muscles and tendons, they are actually causing these motions. Okay, so they are actuators. And if you just look that these are joints, there is actuator and there are some rigid bodies. So the kinematic variables are involved in the description of movements, and they are independent of the forces that cause the movement. So you know the kinematic variables, what is which describes the movement. This I have already discussed in the class earlier. So you need to have that data. So they include linear and angular displacement, velocity, and acceleration. This you can get from the motion capture system, right? The displacement data is basically you can get from markers. So the displacement data taken from any anatomical landmark, center of gravity of body segment, center of rotation of joints, extremes of limb segments, or key anatomical prominences, bony landmarks. The displacement data, you can actually, when you track the markers, you can also get that. And there should be a spatial reference system. Now, this is the reason why we insist you to look into HIP 98, how these measurements were conducted. So if you get hold of the two papers combined with the HIP 98 data, when you dig into it, then these things will be much more clearer. Because I keep on lecturing you kinematic variables, this, that, unless you enter HIP 98, you won't be able to connect what are the measured data and what is being calculated. The general term given to the forces can cause movement this is kinetics. So forces, what are the forces coming in the different parts? That is the kinetic analysis. Both internal and external forces are included. Internal forces comes from the muscle activity, ligament, or the friction within the muscle and joints. But mostly, internal forces means muscle, ligaments, or tendon forces. Okay? External forces are basically ground reaction forces. That data we actually get force platform. The moments produced by the muscle crossing a joint that can be calculated. Okay? So these things are calculated. The mechanical power flowing to and from some of the muscles and the energy changes the body that result from power flow, all considered in the kinetics. So when you are doing the inverse dynamics calculation, finding out the muscle forces using the statically optimization technique, then all these things can be calculated, but that is on a later part. But essentially, when you use the inertial parameter, as I told you, you need the anthropometric data. Now, human movement analysis requires following information: mass, moment of inertia, and their locations. Okay? Joint centers of rotation, the origin and insertion of muscles, the angles of the pull of tendons, and the length and cross-sectional area of the muscle. These things you will particularly the length and cross-sectional, these things you will need for inverse dynamics calculation at the end. Okay. Also the origin and insertion of the muscle. That would actually, as I told you earlier, it will define the joint, the muscle lines of force, muscle action. But initially, you need the along with the mass, moment of inertia, joint, center of rotations, all these things. The accuracy of any analysis depends as much as on the quality and completeness of the anthropometric measurement, as well as kinetic and kinematics. So this is what is given already in the book, chapter 4. You get to know the body segments as a fraction of the body height. Regarding the segment weight, center of mass, radius of gyration, all are given in the book. So that's anthropometric of each segment. Output of the movement can be described by and large kinematic variables, displacements, joint angles, velocities, and acceleration. This comes from the 3D motion system. With the musculoskeletal model and accurate kinematic data, we can predict, or rather calculate, net forces and moments that cause this movement. Okay, so there comes the musculoskeletal model, and with this combined with this kinematic data, we can calculate forces and moments. How it can be done? It has been the following calculations as well as reference to HIP 98 is helpful. Such an analysis is called inverse dynamics. Now, what is the difference between forward dynamics and inverse dynamics? Now, you give a force. In forward dynamics, you give a force and you calculate position, velocity, and acceleration. That is basically position, velocity, acceleration are outputs of forward dynamics, isn't it? Hello? Hello? But what happens in case of inverse dynamics? Here, input data is your position, velocity, acceleration. Okay? And then you use some statically optimization technique, minimizing stress in the muscle, and you calculate the forces. So that's the reason it is called an inverse problem. It's inverse dynamics. That is the basic difference between forward dynamics and inverse dynamics. Okay, there you apply forces and you get position, velocity, acceleration as output. Here you use position, velocity, acceleration to calculate forces. Okay, that's the reason it's an inverse problem. So this way, you just follow one by one, right? It would be easy for you to understand, but you have to first have a go at it. Don't have a mental block, just have a go at it. And I'm there to help you. We are all there to help you. You will stumble here and there. The reason you would actually come up with a project report of how elaborate project report on how these musculoskeletal forces and moments are calculated. Using measurements, using calculations. For that, first you need to train yourself up with the HIP 98 data. Okay. So this is forward dynamics. I was telling you earlier. So you can have this in the forward dynamics approach. You give a force, then you get hold of the kinematic data, position, velocity, and acceleration. So some messages of basically you try to be a bit careful about the masses and the inertial parameters that you use in your calculation, because that would actually give you an erroneous result if you do not use correct masses and the inertial parameters. Okay, or there are unrealistic constraints. So the entire link system will start to generate displacement errors, and these errors will accumulate with time. So you have to be careful with the masses and the constraints that you used in an entire link system. Basically, you have to look at it from the point of view as a kinematic link mechanism. The whole musculoskeletal system comes down to a more mechanical system containing links and joints. So this is basically the flow diagram. So from joint kinematics, you can get joint moments or torques, and then the muscle force calculation that involves a different optimization technique. So we can explain you a little bit more in detail later on, but first you go through the slides and try to download HIP98, and from there on you can first try to understand the overview, because there are a lot of things that are being carried out in modules, but parallelly. This is forward dynamics. Now comes the examples. So you have a link mechanism, as you can see, 1, 2, 3, then the foot, and each segment you have I1, M1, I2, M2, I3, M3. And when you dissociate the links, it's replaced by reaction forces and moments which you are calculating. So these examples you can follow easily. Static analysis, then dynamic analysis. These are two, example 1, example 2. So example 2 is dynamic analysis. Now all calculations are shown, so you can easily get hold of the procedure. So these calculations are shown to give you an idea of the procedure, a summary of the procedure. Okay, so from foot to knee joint. So example 3, how we are calculating the moments and reaction forces at the knee joint. So we are moving up. Started with ground reaction force. The foot touching ground, we calculate the joint reaction force and moment from ankle joint reaction force to knee joint, from knee joint to hip joint. We can move up. So that is example 3. And the 3D motion capture system, you can see this, you have yourself come up with a report gate analysis. Now you would know more in detail when you use the HIP98. So you have the global coordinate system, you will have a local coordinate system connected to a link segment, you will have also markers coordinate system, and you need to do a lot of transformation because you have to convert everything finally into the global coordinate system of measurement. So global reference system, a global coordinate system, and you have local coordinate system, as I told you. So this is fixed to the laboratory, and this is anatomical. Okay, there is also marker LCS, and you have the anatomic limb segment LCS. And this is explained, together in a figure. Okay, you have the marker axis, you see here, M, XM, YM, and ZM, and you have the anatomical axis, which are small x, small y, small z, and this is anatomical axis is centered around the CG of the link segment. But everything is, you have to convert to global coordinate system, X, Y, Z. Okay, so the interconversion of local to global or connecting one local coordinate system to the other local coordinate system are important. So the basic knowledge of robotics in coordinate transformation, precisely coordinate transformation, will be useful. These are the most important, the textbook, David Winters, that I have already uploaded. You can also refer to a paper, but at this moment, it is better to refer to the book. Chapter 5, as I told you, of David A. Winter. Okay, then. So let us come back to the yes. Was it difficult to understand? Hello? Hello?
Oh, no, sir.
No, it's fine. So
No, sir.
Be patient. Yeah. So look into my lecture first, then look into the Basil's lecture yesterday. But HIP 98, regarding HIP 98, today's lecture, whatever is written in the slides is good enough, because you need to download, you have to execute based on the instructions. You can get HIP 98 directly from the OrthoLoad website. Okay, so what I will do, I will upload this lecture, today's lecture, in the class material. Tomorrow, we have only 5 minutes. Tomorrow, I will upload the assignment around 10:55 to 10:57, between that. So you will start doing your thing immediately, solving the problems. Hello. Tomorrow we have a sort of a small class test type. So you will be doing the problem starting from 11 o'clock. By 12, you should finish. I'm keeping 15 minutes buffer time for uploading the scanned copies of your answer sheet. I mean, answer sheet means it will maximum be 3-4 pages. So you will be doing the problem on elbow. So be prepared tomorrow. Anybody who is absent will be marked 0. Okay? Straight away. Let us keep it simple. So 11.11, the sort of exam starts. By 12, you should finish. 15 minutes is a lot of time. If anybody is finished before that, you can upload. But 12:15, it will close.
Sir, how many questions will be there in the class?
Only one. Only one.
Okay, sir.
Only one question. Of course, there will be 3-4 parts on the elbow. Okay, you have to solve the problem yourself during that time and submit as an assignment. It's an assignment, but you have to do it in front of me online. I would like to see what people have learned from the lectures. It's a continuous evaluation, right? It's like, you remember engineering drawing and graphics? We used to give problems in the class and you would solve it and immediately submit it. It's something like that. Okay?
Yes, sir.
So be ready with your pencil. You might have to draw free body diagrams. You need to do it neatly, given the forces, moments, everything, and clearly write the equations, free body diagram, equations, solve it, and then come up with the solution, right? Then you can scan it and upload it. Enough time, 1 hour to solve the problem, plus 15 minutes buffer time for uploading the manuscript. So everybody has scanner, Adobe Scanner, so it would not take too much time to scan it and upload it. Okay? So we are almost at the end of the class. So after the class tomorrow, we might have a little discussion so that you get started with HIP 98, right? Okay?
Sir, will we be provided the anthropometric data, or do we have to look that up into the table?
No. You don't have to look up into any data. All data will be given for you tomorrow. Don't worry.
Okay,
Tomorrow we are not using anthropometric data as such. Static analysis. Whatever I have taught you, I have given you document on elbow, particularly the biomechanical analysis of elbow, the problems that I have solved and asked you to look into it. You please look into it and get ready for the assignment tomorrow. Okay, then I'll see you tomorrow.